Right, so now we will solve this problem. If you see here, the question is given for the situation shown, calculate the water level D. So if you see here, we actually need to calculate the water level D. This is the water surface. You see the water level, this is the air space. So this is the air water interface. This length is L and this is the height D. This is the the free surface actually. You can see here this is the free surface. So the question is for the given situation, calculate the water level D inside the inverted container. So this is the inverted container, and the manometer reading has it is given 0.7, and the depth L is 12 meter. So this depth it is 12 meter given, and this height this is the manometer reading for mercury, this is given 0.7. We need to calculate the the depth D for this section, that means the water level. If we try to solve this problem, so what we can do is maybe we can define some points. So if you already know from the previous theories I discussed earlier how to measure the pressure measurement. So here actually I want to show you a couple of things. Let's say put some name. Let's say this point, this is A, okay, and this point, let's say this is B, okay. So we can say we said this is A, this is B, and now we will say okay, this point, this is D. Similarly we can define this is E, and maybe this point, this is F. So just different notation we need to solve this problem. So the important thing is, if it is point B, so pressure at this point we can say this is PB. And here, if you see, this is the open container, the tube. So at this case it should be the atmospheric pressure and the gas pressure. We can say this is the zero pressure, because this is the gas pressure, okay. So this on it should be 0, PB, it should be 0. Similarly we can say the pressure at this position A, it is also 0, because it is also the open surface. You guys already know that pressure is directly proportional to the height above the water surface. So what is the height here? What is the height here? So if H equal 0, so you already know pressure P equal rho G H. So if H equal 0, then it is rho G into 0, so it should be 0. Okay, so now we got, I believe that you are now clear actually, the pressure here 0, pressure here 0, okay. But here you see pressure at this point it is not 0. You see it is the open on the atmospheric pressure, but here you see it is inside the tube. So at this point there should be some pressure. So if we start solving this problem, so we know what is given, the density of water, it is, we know 1000 kg per meter cube. So we have two different materials, water, and we said this material it is mercury, okay. So then if we define the density of mercury is rho Hg, it is 13,600 kg per meter cube. So this is the density for mercury. And from this problem we found PB and PF. This is actually the zero pressure. It is we got from the the schematic that what I showed you earlier. If you can remember, I told in my previous video, that means if you already have went through the the theory, that the video which I uploaded in my YouTube channel. So I said pressure is proportional to the height. Okay, so that we said earlier, actually it depends on the height, and we know from the formula pressure equal rho g H due to the height. So now what will be the pressure at this point A? So at the same height, pressure should be same. So that means at this point A and here, the pressure at this point and this point, it is same. It is not different because of the height. It is the same height. So when we will calculate the pressure at this point A, you can see the water level, the height is here. The corresponding height is H. Okay, it is H. So that means at the pressure at this point is rho g H plus the pressure of this point PB. If you went through the videos which I showed you earlier, so that means the pressure at PA at this point, it will be the PB pressure at this point, and the density of mercury and G H. Here you need to keep in mind this information. The material is mercury. If you see here, the material is mercury, and the only force is the body force is the gravity, and the density of the mercury and the corresponding height rho g H plus the PB, the pressure here. And now the PB, this is actually 0, so it should be rho H G and G H. So this is the pressure for position A. Okay, so we got this, the pressure at position A. Now what will be the pressure at position D? So if you see here, let me just show here again. What is the difference between this point A and D? You can see this is the airspace. This is the airspace, air, and see what it is. It is empty. That means this is air. So at this surface, this is also air. This is also air. Only the air column A, and this point we say this is D. So the air column changes, okay, but the pressure change due to the air column AD is negligible due to the air density, okay, because the density is same. So the column changing, but due to the air density, the pressure at this point and this point, there should be some variation. I'm not telling it is equal pressure at here and here, but the difference is really negligible. So you don't need to worry about this. So we can't say this is equal, but we can say, okay, they are very close. So what we can say is the pressure at A is equivalent to pressure D, because I didn't say that this is equal. Okay, so you can, if you want, then you can write the pressure change pressure change due to air column AD is negligible due to air density, definitely low air density. Okay, so due to low air density, so air density is not significant at this section. So due to the low air density, we can neglect the pressure difference. So we said this is negligible difference. So now what we can do is we can write it like this. So if I say that pressure at A and pressure at D, it is, let's say this is equal. So rho has the mercury height and G has. So this is, we said the pressure at this point A and D, it is equal. It is actually equivalent, but we said it is equal. Now the second part is we calculated the pressure at A and D. What is the pressure at this point E? If we consider this section for E, you see the material, it is water. If you see the left hand side, the height, it is D. Or if you consider this section, this length, it is given L. So if we consider this part, so pressure at this position is will be the pressure here and pressure due to this height. So I believe that you already went through the videos that I uploaded for the, especially for the theories. I discussed a couple of options how to measure the pressure. So at this point, if we want to calculate the pressure at E, it will be the corresponding the water height, that means the pressure here, and the pressure due to this height, that means it will be pressure PD plus rho G D, not H's, rho G D, and rho density, it should be for water. Let me write it down and then it will be clear for you. So we can say the pressure E equal, the pressure D plus density of water, I said just W, into gravity and the depth. It clear now? So this depth, the density of the water, and the gravity. Gravity is the only body force that will act with this sort of problem. So now we got the pressure E for the left hand side. Similarly, you already know the pressure at that section A, if it is 0. So I wrote it earlier, pressure here, it is 0. Can we write the pressure at E, it is equal, if we consider the left hand side, can I say the pressure at E equal pressure at F plus rho GL? Yes, we can. This is the height L. So similarly we can say, we can say pressure at E, it is equal, that point pressure at F plus rho. Okay, definitely this is the water, gravity, and L. So for static equilibrium, you see, we found pressure equal this, pressure equal this. So for static equilibrium, we can write PD plus rho W GD. You see, PD plus rho W GD, it is equal to PF plus rho W GL. Can we write it? Yes, we can. So we can simply write it, but this PF, this is equal 0. So then we can write it like this. PD, this is equal rho W GD and rho W GL. It should be plus. Okay. So now if you can remember, we said PD, see, we said PA and PD, they are equivalent. Okay, PA and PD are equivalent. So can I write it like this? It is PA plus rho W GD equal rho W GL. Our ultimate target is we actually want to calculate this D. Okay, so we actually want to calculate this D. the depth. So now guys, we know the pressure at this point A. This is the density of mercury and G H. And this is density of water, GD. This is density of water and GL. If we simplify this relation, then D, it will be the density of water, L, minus the density of mercury and H over the GW. Okay, so just let me think about it. So it will be what we can do, we can, sorry, it will be rho W. It will be rho W because we can simply cancel out this gravity. We don't need this gravity anymore. This is not important for us. So it will be the rho WL minus rho mercury and H over, it will be only rho W here. So now we know the density of water is 1000 and the length is 12 meter. The mercury density is 13,600 and it is 0.7, and this density is given 1000. So the depth, you see, it is 2.48 meter. So this is the D, the depth which we calculated. So what we did guys here, if you just have a quick look, what we did so far, we said the pressure at this point B, it is 0. This is the gas pressure. You see, this is the open surface. So similarly, the pressure at this point, it should be 0 as well. And it is very important, you should keep in mind that pressure at the same height, it is equal. So pressure at this point and this point are same. So you don't need to think about this below section. So when we calculated pressure at A, it is equal to the pressure of B and this corresponding height. So it should be PB plus density of mercury and GH. You see what we wrote here? PA equal PB plus rho GH. But PB, this is the gas pressure, it is 0. And D is the similar surface you see, like A and D. This is the similar, the water, the air surface, the open surface, and the pressure difference at A and D, it is negligible due to the low air density. So we say pressure A equal D. We write it down here, and then we calculated the pressure at this position E. So pressure at E, it will be pressure at D and rho G D. Similarly, pressure at E equal for this side, it is pressure at F and rho G L. So that you can see here. We just write it down here. The pressure at E equal PD rho GD. Similarly for left hand side for PF and this. So for static equilibrium, we can say this pressure PE equal this one, and we substitute PF equal 0 and PD equal PA. Then some simple simplifications. We substitute all the values and we got the value D equal 2.48 meter.